so Z1, that we knew that that was negative 1.41. We're using this formula again, the Z equals. For the negative 1.41, our value of x was 1.8. So we're going to stick that in here. So we've got negative 1.41 equals 1.8 subtract mean over standard deviation. Now we don't know either the mean or standard deviation, so we leave it as it is. Now at some point we're going to have to rearrange this. I might do it now before we we find the next one. So I would have to get rid of this. What happens to it?
Multiply
by the other side, yeah? So I'm going to have negative 1.41 standard deviation equals 1.8 subtract mean. Normally when we do what they called simultaneous equations, we have both our unknowns on the left and our number on the right. So I'm also going to add the mean to both sides. So I'm going to have mean subtract 1.41 standard deviation equals 1.8. Okay, so I've now formed myself one equation with both of my two unknowns. Très bien. I'm now going to repeat that same process with the other z-score. So this baby is going to go. We decided not to do that question. Oh, no. Oops, daisy. Oops, daisy. Alright, so now we're going to do the same thing here with this value here.
We just rearranged it.
Alright, okay, so now we're going to do the same thing with the other value, so the Z2, which was 1.60. So we're going to have 1.60 equals 2.4 this time. Subtract mean over standard deviation, and lo and behold, same thing happens. It becomes multiplied there. And remember, especially if we're using the calcs to solve this simultaneous equation, we need to have our unknowns, our unknown variables, in the same order. So I'm going to do the same thing, and I'm going to bring my mean to the front, plus 1.60 standard deviations equals 2.4. That has now given me two equations with two unknowns. And we say to ourselves, aha, I now need to solve those. Do we remember using polysmalt to solve simultaneous equations?
Yes,
Okay, so this is a recap if you had forgotten. So we're inputting our coefficients of our variables, and remember that's why I said that we needed to have the variables in the same order. And our calculator will talk about x1, x2, and we know that our x1 is representing our mean value and our x2 is representing our standard deviation, because that's the order we have them in. So let's find it here. So in apps, polysmalt 2.
We deleted also except for GCS.
Yeah, we deleted lots of things. But this is the board one that I think it's a bit different. So hopefully it's not a surprise. It's number 2.
Where's it in that?
Yeah, in apps, polysmalt. Remember, this screen we can ignore. It tells us our answer is going to be given to us as a fraction. If you would rather have it as a decimal, you can change that one. Now it's into a matrix. And so I'm changing mine to be a decimal value, and I hit this button to say next, and it looks like this. And then remember, this is where we put the coefficients in. So our coefficients are 1. Yeah, it always has. And then negative 1.41.
No, that's not how we use it.
Oh, why I've got an extra number? Oh, Miss Harrison.
Wait.
1, enter, didn't press enter. Negative 1.41 goes in next, and then 1.8. So I've just inputted the information from my red equation. So the coefficients were 1, negative 1.41, and that was equal to 1.8.
Wait, where did the 1?
Because it's the coefficient of the m. So for the blue one now, what's my coefficient of m? 1. What's my coefficient of the standard deviation?
1.6.
It's positive 1.6. Okay, so I'm just going to type 1.6. And it's equal to 2.4. Oh, I didn't do it again. 2.4. Okay, and then we press solve. And remember, as I said, because we've put our mean values in first, the x1 represents the mean. So we hit solve. And there we go. So our mean is, oh, mine's going to disappear. My mean is 2.04, was it? Oh, was it? Mine said 4, didn't it?
0.95.
2.05.
I still 2.0. I got 2.0. Yeah.
What's that the mean is
What?
Are you wrong, Miss Harrison?
What have I done wrong?
I have 0.95 Miss Harrison.
Oh. Alright, okay, so now I corrected my value that was in wrong. We've got 2.08 and 0.199. Oh my god. 2.08 and 0.199. Yeah, so that's our mean is 2.08 and our standard deviation is 0.199. Always have a little look to check that that makes sense given your question. Okay, so would it make sense that this number in the middle here would be 2.08? Yeah, looks pretty good to me.
So
Your standard deviation, you're never really going to know for sure whether it's right or wrong, but as long as it looks, and you know it's going to be a small number just because these values here are quite close to that mean. Yeah? Are we happy with that?
Maybe.
So as I say, these kinds of questions are more common these days, joy upon joys, because it's testing your knowledge of the Z-score as well as knowing how to use your calculator for the inverse normal. All right,
is that it?
the end.